Hi everybody, I'm Professor Rad, and today we're going to talk about some key term definitions for an elementary statistics course. So let's start by defining statistics, since that's what we're here to study, right? So statistics is the science of collecting, displaying, analyzing, and interpreting large amounts of data. So basically what we're going to study in this class is how information is gathered, how that information is shown to other people, how that information is used, and how that information gets interpreted. So in this process of statistics, there's really kind of two little subgroups of stats. The first is called descriptive statistics. And the second one is called inferential statistics. Now, these two things do kind of what they sound they do. So descriptive statistics, we've got describes. So when we're engaging in descriptive statistics, we are examining the different procedures that are used to collect and describe information. So how do we gather information and how do we sort of summarize that information? So for example, if I wanted to know what's the average age of a person living in the state of New York, how would I get information about that? And how would I then declare an average? How would I pick one number to represent the whole state? The inferential statistics has this word infer in there. So an inference, or when you infer something, it's kind of like when you finish each other's sandwiches. So in inferential statistics, that's the study of how you make a conclusion about that big group based on a smaller group. So for example, if I wanted to know information, maybe not just the age, but maybe I want to know what kinds of jobs do people have in the state of New York, then that whole group, the whole population of New York is the population, the big group I'm interested in, but I might not be able to get data or have conversations with every single person. So I'm going to maybe survey, a few people from across the state, maybe like 50 people from each county or something along those lines, and then use that information to make a prediction or conclusion about the entire state. So that whole group we care about, that's called your population. And then the group that you actually study, that's the sample. Now, I have this tendency to talk about populations and samples in terms of people because that's what most of our examples are going to be, but it doesn't have to be. For example, if I want to know whether or not a particular automobile company makes great vehicles, then the population of that data set would be the vehicles made by the company, and then the sample would be the vehicles that I'm looking at. So maybe I look at 100 vehicles and test them for safety regulations, and then based off of that, make a conclusion about all the vehicles that they're creating. That conclusion I would be making would be inferential statistics, and how I chose those 100 vehicles to look at would be the descriptive statistics. All right, now, one of the things that we're going to be seeing a lot in our statistics class is words. Statistics is super applicable to like every area of study, but that does mean in terms of a math class, we're going to be having lots of word problems. So I recommend you get a highlighter or something along those lines to help you dissect and understand what information is being presented and what's going to be important for what we're looking for. So I'm going to model techniques that I usually use when I'm getting started learning how to analyze and process information given to me. Ultimately, you need to use the technique that works best for you. But if you've always struggled with word problems in math, hopefully these techniques I'm going to show you this semester will help you out a bit. So the first thing I'm going to do is read through, oh gosh, first thing I'm going to do apparently is hit my phone here. But the first thing I'm going to do is read through this example just to kind of get a sense of what's going on. Then I'm not going to try and answer the questions, but I'll read what the questions are. And then I'll go back, reread the problem with those questions in mind, and try and figure out what information is important. So let's go through that. This example says, a study led by Andrea Meltzer examined data from 169 first married newlywed couples whose marital satisfaction and weight were tracked over the course of 4 years. Meltzer found that on average, spouses who were more satisfied with their marriage gained more weight over time, and those who were less satisfied in their relationship were likely to gain less weight over time. Okay, so let me process what this just said. So Andrea looks at some newlywed couples, sees how happy they are and also how much they weigh for 4 years. And they find that happier couples have gained more weight and unhappy couples gained less weight. Okay, so it's kind of me processing, understanding what's going on here. Now let's look at the questions we're being asked. So the first one says, what sample did she use? The second one says, what population is trying to be described here? And then the third one is going to ask us to compare that sample and that population. So let's focus first on these identification ones. So the sample and the population have to do with what group we're looking at and what group we actually look at. So who we're trying to describe and who we actually describe. So I'm going to go back and reread this, looking for information about who is being described. So first, she examined data from this group of people. So this specific group of people is going to be our sample. That's a specific group that she looks at. So actually, I'm going to go put that here right now. So the specific group, the sample, is this 169 first married newlywed couples. That's the specific group that was looked at. 169 first married newlywed couples. And then when I look at their conclusions, it says Meltzer found that on average, spouses who were more satisfied with their marriage gained more weight over time, and those who were less satisfied gained less weight over time. Okay, so sometimes they will tell us the specific population. It'll say something like, Andrea Meltzer was curious about how satisfaction in a marriage is correlated with weight gain, right? They didn't say that here. They didn't preface us with any information about why she was doing this study. And if they had, that would have made this question easier. So if they had prefaced this with, Andrea was curious about whether or not the happiness of a marriage could impact how much weight you gained, then the population, I would say in that case, would just be married people. I'm going to put that here as one possible population. That's also the group that when I summarized my understanding of this situation, that's the group that I said, right? People who are in happy marriages versus people in unhappy marriages. I was just talking about married people. However, for our class, I'm going to be kind of a stickler about who the sample is because that they will specifically tell us. But in terms of a population, if they don't tell us, then you could kind of make different inferences. So for example, maybe you read through this and you would have summarized it differently. Maybe you would have said, well, based on this, we can conclude that newlywed couples gained more weight or gained less weight. Or maybe the first married stuck out at you and you said first married couples. So any of these would be acceptable definitions or like answers to what a population this study was trying to describe. Generally, you want to be thinking of kind of bigger group when you think population. I would not put the 169 as part of the population here, because that 169 is that group of people specifically looked at, not the bigger group we're trying to make conclusions about. So I'm going to be a little bit more relaxed with answers for population, unless it specifically tells it to us. I'm going to be more strict about the specific sample. Now, part C is asking us, does this sample suit our desired population? So when I'm trying to answer a question like that, I'm trying to see, is there anybody in the population that is missed by the sample that we looked at? Or is there anybody in the sample that doesn't belong in the population? I'm also thinking about things like, well, in this study, the things that are missed or represented but shouldn't be, can that have an impact on the results? So those are the things going through my mind. So for example, if I'm thinking my population is married people, I'm going to say no. The sample does not fit or doesn't suit that desired population. And that's because married people could be people who've been married for a long time, could be people who are in second marriages. Maybe they got divorced or they're widowed and then they get remarried. So this sample would miss those types of married people. And if you've been married for a really long time, you might just naturally have gained weight because of age or lost weight because of age, or your marital satisfaction is going to be impacted by whether you're newly married or whether you've been married for a long time. So the things we're studying are impacted by when the couple was married and whether or not they're first married. So I would say this sample does not fit this population. For this one, same thing, primarily because of this first married cohort. So you could still be a newlywed couple, but be in another marriage, right? So I would say the newlywed couples, if that's my population, we're closer. I'd say we were closer than if we were just trying to describe married people, but we still haven't met that population well. And then first married couples, I would also say no. Again, because this sample has newlyweds and this target population doesn't say how long ago the people were married. Now, if I had stated as my population first married newlyweds, then that sample would fit that desired population. So your answer to C is going to kind of depend on what your answer to B is. And your answer to B is going to be variable, right? Could be different things. But those are the things I think about. So one of the things we're learning here about statistics is that it's not always cut and dry when we're making our interpretation. And that's something new about a math class. And that's why you might have heard statistics is hard. It's because like in algebra, you solve an equation, you get an answer, easy peasy. But in statistics, there are multiple answers that you could potentially have. I mean, sometimes there is one right answer like we had for sample, but other times there are different kinds of answers you can get, like for population. So to me, it's not the math component of stats that makes it a challenge, but it's this like, it's this like no specific one right answer to some of the questions, while other times there being a specific right answer. Okay, so you really have to kind of reason and think through and be able to explain your responses. All right, so I have just 2 notes to summarize these results, and that will wrap it up for this video. Okay, so the first note is that before you even begin your study, it's going to be important to identify the population you care about. So in the example we just looked at, if Andrea Meltzer was looking, if she was interested in first married newlywed couples, then that makes sense for the sample she picked. But if the population she was interested in was just married people in general, then that was probably not a good sample. So before you do a study, you want to make sure you identify the population. This is also the case even if you're not doing the study, but if you are reading a study, like if you're doing a research paper, you might see something that says maybe something like people who have dark hair tend to live longer. I don't know, I'm making that up. but maybe that study was done on a group of people over 50. Who knows? So in that case, there might be some other variables at play. So when you're reading a study, it's important to identify what sample they used and see if that describes the population you're trying to research. Then when you're doing your study, you want to, when you're determining your sample rather, you want it to be as representative of your population as possible. So you pick your population, and then based on the group that you're interested in, you pick a sample that's going to represent that. So you pick a group of vehicles that belong to the manufacturer you're interested in, for example. And you make, maybe in your sample, you have each type of vehicle they make so that the type of vehicle doesn't influence your results. So in the next video, we're going to start talking about that. How do you draw a sample? There are different types of samples that you can pick in order to get that representation. So I'm looking forward to seeing you then. In the meantime, have an excellent day.